Okay, so I am back with a new update. I added a gearbox. So I didn't really tell you in the future, but I think I did. I don't know. I don't really rewatch the videos after reposting them. I post them, watch them, and then post them and then never watch them again. So this is supposed to be a QDD actuator, a quasi-direct drive actuator, which has aspects of a spring. Don't mind that. I was painting today. So 4-to-1 gear ratio. I asked ChatGPT to do some math based on, my motor specifications. It says this thing's supposed to give me a Newton meter of torque. Don't believe it. It says it's supposed to lift about 1 pound. I don't know, because isn't a Newton meter like 9-something pounds? I don't fucking know. But I haven't actually done weight testing. I've only done actual testing, so. Fuck, my hands look terrible, nigga. You see? Fuck. It's actually kind of hard to move it. The initialization cycle is pretty stupid. It simply does a bunch of bullshit and then, figures out if it wants to go. Holy cow. Terrible camera quality. We'll go to 1. So, just as a wider area, so as you see, my laptop turned off. Stupid thing. So, as you see, you turn that off. My readings are the motor mechanical angle, which is the angle of the AS5600 sensor. My shaft velocity, because I was trying to get some runaway thing issue. Because if this motor exceeds a certain value, it starts spinning randomly. But because I have hard end stops, it's not really an issue anymore. And the torque is pretty high. The target angle is based on what I input here. And the final drive sensor, which is this, is simply, just a sensor. So the initialization starts. It moves till it passes 0. Once it passes 0, it finds some random, does some bullshit math. And yeah, the code doesn't really work as intended, but it does work enough. So, what I can do is run a test. So, right now the motor is at 0 degrees. I'm able to mechanically move it to 0 degrees where I want it to be. And from there, I'm going to point my camera at the motor. I'm simply going to tell it to go to 90 degrees. So 90, enter. As you see, the velocity is stacked all the way up, so that is maximum speed. As you see, now it's back to 0 degrees. And it goes from 90 here, 0, negative 90. So that's 90, that's negative 90. Oh, sorry, that's 90, that's negative 90. So 0, 90, negative 90. And it can go to 180 or 360 or 400 based on how many rotations per minute it does, because it actually calculates it as a 4-to-1 gear ratio, which it is. A 12-tooth pinion to a 24-tooth gear to a 48-tooth gear. Did the math, and apparently that's 4-to-1. I think. I hope it's 4-to-1. If it's not, well, I don't know why it works so well. It's going to have to stay like that. So, as you see here, I can put in the value of 90 in the serial monitor. When I click enter, it goes to that angle at maximum speed. And it, tells me a bunch of bullshit. And as I do it, so I go 0, the velocity is a little delayed, but it tells me the velocity as it's going. Can't really change it because, well, it's at its maximum speed. The thing is, it's not going to give me full torque, considering the fact that I ran this motor through the ringer. I did a bunch of stall tests and everything, and this thing got really hot. It even burned my finger. It actually got so hot that the magnets inside got demagnetized, because when neodymium magnets come under heat, the structure changes and, well, the magnetic effect weakens. So, that's why you spend money on random shit. Because I have a perfect replacement motor, no solder, and it's simply 2 screws at the bottom, so I made that jig with 4 screws around, so I can unscrew the top pinion, put it in here, stick out the jig, put it in the bottom of here, resolder the wires, slot that motor in, and I'll back up to max torque. But for now, what I'm doing is pretty good. There isn't a top plate. Well, there is, but, well, it's working on some type of composite bond structure. So it kind of broke. So what I would use is a type of thick stock paper, which is coated in super glue. And once it bonds, it creates a very hot reaction due to it bonding to all the fibers, creating a very strong structure, which is then sanded smooth. So even though this looks bumpy, it is actually completely smooth. To the touch. Microscopically, it's not smooth at all. So this area here would be on this, holding that together. And this would be on that, holding that around, covering and shrouding the gear. So that is basically it. Could I get it to do a dance? Shit. 12. No. If you type in that number, it's gonna try to rampage and fucking destroy itself. So let's go 12 degrees. And just so you know, it's able to go really tiny. So go back to 0. Yeah. Family's bad. Anyways, bye.